I want to talk about Chapter 3, Lesson 3 of Jacob's Geometry book today. My first YouTube video, I might be a sensation. You knew me before I was big. Don't forget it. I wanted to talk about last week, we went over the protractor postulate, which is really similar to the ruler postulate that we had done back in the fall, pretty much mirrors it, talking about the coordinates and how to measure coordinates, and in this example, how to measure angles and how to compare them, including the absolute value, the difference of the absolute value of the difference being how you find the measure of angles. The other thing that we talked about, we closed talking about angles, and handy dandy chip clip makes a really good way to talk about angles. So we talked about acute angles, and we talked about right angles. Of course, let's see, just about correct. And then we talked about obtuse angles, measuring anywhere between 90 and 180. And also we had lots of great questions about straight-ish angles, straight angles. And thinking about it even more, I just think that there's no way a straight angle could conceivably, even outside of the realm of geometry, have a midpoint. I really enjoyed that discussion last week, though. Okay, so let's get on to some new stuff. Well, actually, here, let's go back in the past for just a moment. We learned in the fall also, betweenness of points theorem. There goes my face. B is between, this is the definition, B is between points A and C, written this way, A, B, C, if and only if either A is, which one is that backwards, less than B, which is less than C, or A is greater than B, which is greater than C. In this section, we have almost the exact thing having to do with rays, the betweenness of rays, and I've drawn some pictures so that you can kind of see what I'm talking about. If you're given this angle, COA, then this ray OB is between the rays OC and OA. And here are some ways that it might look. It might look like this, or like this with an obtuse angle, or like this with a straight angle. So OB, the ray OB, remember you have to do that little ray mark over the OB, is between rays OA and OC. And you write it exactly like you wrote the betweenness of points. If and only if either A is less than B, which is less than C, or fill in the blank. I'm guessing that you got it. A would be greater than B, which is greater than C. And that one, so when you measure an angle, you start from this side, and the angle measure gets greater, 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 until you eventually get to 180 degrees. So another way of saying this, or another image rather, would look like this, with O still as the vertex. But in this case, you might have C over here, and A up here, and B is in the middle. So that would be the case where A is greater than B, which is greater than C. Just means it's angle measure, or sorry, it's coordinate that you assign to it. Okay, and and I just get to throw the paper out when I'm done with it. The next is the betweenness of points theorem, going back in time. If ABC, then AB plus BC equals AC. And I think you can imagine what it's going to look like with rays. Ray, hi ray. The betweenness of rays theorem is very similar. If, right? Ooh. If you've got the ray OA, the ray OB, then the ray OC, then their angle measures, and I drew a little picture so you can visualize it, angle AOB plus BOC, if you combine those, you get the whole angle altogether. So once again, exactly like the stuff we did back in chapter 2. The only new material is a new vocabulary word, and it's bisect. And a ray bisects an angle if and only if it is between the sides of the angle and divides it into two equal angles. Okay, if you can picture that, a ray bisects an angle if and only if it's between the sides of the whole angle and it divides it into two equal angles. Okay, and just a reminder for a definition, this if and only if word right here means that this statement is true and also its converse would also be true. So if a ray is between the sides of an angle and divides it into two equal angles, then it bisects the angle. Remember, because for our converse, you just take the hypothesis and the conclusion, and you just switch spots. And for a definition, the conditional statement and its converse must both be true. Okay, so what we just learned was that, what did we just learn? Oh, right. Okay, so how the word bisect. So to bisect in geometry is very specific. It divides it into two equal parts. Now you can imagine this is going to lead to a theorem, the angle bisector theorem. And what that says is that ray that bisects an angle, what it does is it divides it into angles not only that are equal, but for this theorem, half as large as the angle itself. So if you have a book. So a ray that bisects an angle divides it into angles half as large as the angle. What that's saying is I have this angle here, a ray I'm going to form, not too bad, not too bad. So what that says is that this angle is half of this angle. Okay, so that's our new theorem for this week. And I think that pretty much sums up the material from this lesson. I didn't get any homework questions over the weekend or early this week. So if you have any, please bring them to class. I have one more little mini test for you. Okay, a line segment has, finish that theorem. Or is this a postulate? It's a midpoint postulate. This is a midpoint postulate. And I just gave it away. A line segment has exactly one midpoint. So bravo to those of you who got that correct. I'll see you in class on Friday. Thanks.